So let's kind of take a step back then and say, well, how can properly implemented MLOps help me in the current global situation that we have, where we're now all suddenly working from home? And in brackets, if I'm a data scientist or a manager of data scientists. Well, the answer to that question comes down to the collaboration piece that I mentioned earlier. So let's kind of do a deep dive on collaboration. So there are two fundamental modes of collaborating between different people doing work. There's synchronous and there's asynchronous. And synchronous collaboration is when people are sitting in a room together and they're interrupting each other when they have a question and when they need to get something done. And in particular with machine learning, it might even be that they're sharing an environment. So they might even be pair programming, sharing a text editor. So they take it in turns to use the keyboard. They would be working on exactly the same data set in exactly the same environment. And then you're kind of time slicing it. Well, hopefully pair programming is effective, and okay, so people can't make changes to this thing at the same time, but we just kind of take it in turns. Or there's an asynchronous approach, which is to say that different people should be able to work on different copies of things. And the problem with an asynchronous approach, of course, is that you then need to be able to cope with conflicts, like merge conflicts in Git. Which takes me on to the second point here, which is how do software and DevOps teams do it? Well, with GitHub, basically, and tools that are like GitHub, like GitLab and Bitbucket and all of the tooling around that. And the way that works, as I'm sure most of the people in the audience know here, is that you can fork someone else's project effectively, or or you can make a branch from master. You can make some changes in your branch, and while you're making the changes in your branch, you're not treading on anyone else's toes. And when you then propose those changes back to the master branch, that's when you can pull in new changes from the master branch and integrate them into your branch. And that's when you have to deal with merge conflicts. And then you can propose a version of the change which is up to date with respect to the master branch. That's basically commonly known as Git Flow. And it's been very successfully used in pretty much every team on the planet. People have tweaks to that approach with multiple master branches and so on, but it's all fundamentally the same idea of asynchronous collaboration. And then with DevOps teams adopting things like GitOps, where your source of truth for what's running in production is also in a Git repo, well, you can use tools like Terraform, or you can version control your Kubernetes YAMLs, and then happy days. You can use the same collaboration approach of pull requests when you're deciding to scale up the cluster or deploy a new database and doing the other things that DevOps teams do. So what are the challenges applying asynchronous collaboration to machine learning? Well, they are numerous. The first problem is that Jupyter notebooks don't version control very well, and a lot of data scientists use Jupyter notebooks. Another challenge is that data versioning and data sharing is difficult in a machine learning context. Sorry, in a collaboration context, because you can't very easily put your data in Git. There is a project called Git LFS, but it has some significant restrictions. And so what we find is that teams normally just don't bother with data versioning, and they just rename files or rename folders and have folder names with like _final and _final v2. And all these funny little strings that refer to the things that have been done, and then they have to share those folders around, and it becomes quite messy. The other thing is metric and parameter tracking. You didn't have to do that when you're doing software, but you do have to do it with machine learning. You have to keep track of which parameters you used and which accuracy score you got, because models aren't either sort of green or red. They're not either working or broken. They're kind of somewhere in the middle. And the metrics, like the accuracy score, will tell you how good a model is against a certain test set. And so you need to keep track of that, and you could put that in the Git commit message, but then you have to have a human remembering to do it, and people are bad at remembering to do things. Or you can use tools that help you with experiment tracking. And there are challenges with using a combination of local development environments. So you might have a GPU or an IPU in the machine at your desk, or you might be using machines in the cloud. And with Git, it's quite easy to switch from a local machine to a machine in the cloud or a machine in your data center. But doing it effectively with machine learning, where you've also got data that you need to move around, and you've got to keep track of metrics and parameters, and maybe you can't even really use Git with your Jupyter notebooks and still do effective collaboration. It makes it all a lot more challenging with respect to kind of moving around where you're doing the work. And so there are some tools that that help to solve these problems for machine learning, and it's actually a very exciting space, and there's lots of new innovation happening around this. And so obviously, I'm from dot science. I'd love it if you started using dot science, but I also wanted to give an acknowledgement to the fact that there are lots of other tools out there. And so MLflow is quite strong in the experiment tracking space. Weights and biases is very strong in like comparing the relationships between metrics and hyperparameters. DVC is a promising project in terms of doing data version control, as is a project called Pachyderm. And then in terms of diffing and merging Jupyter notebooks, there's an open source project called NBDime. In fact, many of these projects are open source. And so what we've tried to do with dot science is bring the capabilities from these kinds of capabilities into a single tool.